In this lesson, we will discuss polynomials. The use of the calculator is allowed on this section. So we're going to start by comparing two groups. Each of the expressions in this category represents a polynomial. Each expression in the bottom category is an example of an expression that would not be considered a polynomial. And we want to take a minute to compare the two groups and develop a definition of a polynomial. So as we're looking at these two groups, one thing we want to look at is the exponents. Polynomials must have whole number powers. So as we look at the top category, each of the polynomials has a whole number as its power. We have a whole number here, this would be 1, we have 3. So if I went through each of the examples in the top, every single one of them has whole number powers. Now when I get down to the bottom category, the reason I could eliminate this first option is that I could rewrite this as 5 halves x to the negative first, and that's not going to be a whole number powers. The whole numbers would be 0 and bigger. Then if I look at the second example, this one is not going to be considered a polynomial because if I were to rewrite this, I'd have 4y in parentheses raised to the 1/2 power, or even 2y to the 1/2. So in this situation, again, I don't have a whole number as the power. Here I have a variable as the power, so that would be an issue. And then down here, again, I've got that fractional exponent, so that's not a whole number. And then finally, again, since I have a variable in the exponent, that's not considered a whole number power. And then the other rule is that we're not going to include log or trig expressions when we're talking about polynomials. So that's going to eliminate those last two options. Now, a polynomial is in standard form if the like terms are combined and the terms are arranged in order from the highest degree exponent to the lowest degree exponent. So we'll take a look at the examples below. These are in standard form. And the reason is if we look at the degree of this monomial right here would be 4, this one is 2, this one is 1, and then that power would be 0. So they are in descending order, decreasing. 3, 2, this would be to the first, this would be to a 0 power, so again, descending order. And then the same thing holds true for the last example. These polynomials, however, are not in standard form. We can see right away the degree here is 0, this would be 1, this is 3, so they're out of order. And then the second one is actually not simplified. So we would need to do a little bit of work here. We'd have to distribute that negative in, and then nothing would combine in this situation, but we can simplify. And then the same thing happens with our last example. Again, it's not simplified. The first two could combine, and then once we combine this, then they would be considered to be in standard form. So now you're going to take a minute to write each of these in standard form. So remember that if you need to do any combining like terms, distributing, things like that, you're going to do that first, and then you need to make sure that the terms are in the correct order. And now if we look at the answers to these, we're going to see that in number 1, as we rearrange this, the 5x to the 5th is going to go first. Something to keep in mind with all of these is we want to make sure that we're keeping the coefficient, the number that's in front of the variable, and then also its sign all together. So I can't just write this as 7x to the 3rd, the negative has to come with it. 3x to the 2nd would be next, followed by 2x, and then the constant would be last. For number 2, again, I look for the highest degree first, and that's going to be 2y to the 7th. After that, I have a 6th degree, so I've got y to the 6th, followed by negative 5y to the 5th, then 3y squared, negative 6y, and then plus 4. In example 3, my highest degree is going to be 6, so I'll bring that whole term to the front. The next highest degree would be to the 5th, so that one goes next, followed by the 3rd degree, so 32w to the 3rd is next. And then finally, we've got minus 2w squared and then minus 2. And then for number 4, there was a little bit more work to do here. We do have to start by distributing this negative in. So then that's going to give me this line right here. When I go to write things in standard form, the degree of 6 is going to come first, so 12y to the 6th is first. I'm looking for degrees of 5, then 4, then 3, which I don't have any of those. The next one would be 2. So I've got 12y squared and 6y squared. Those two can combine to give me 18y squared. And then after that, I've got negative 3y, which has nothing to combine with. and then finally minus 4. So those are our final answers. Now we talk about different types of polynomials. A polynomial is considered linear if its degree is 1. So what we do is we look for the highest power within the expression, and in this case, our highest power is going to be 1, and that's why we say that the degree is 1, and the name of that is linear. The next type we look at is quadratic, and this is a degree of 2. So once again, I look at all of our variables here and their degrees. So the degree on this one is 2, the degree on this one is 1. The highest one tells me the degree of the entire polynomial. Since that's a degree of 2, we call that quadratic. The next one has a highest degree of 3. A degree of 3 is going to be called cubic. And then our next example has a degree of 4, and then that's going to be considered quartic. Now, the number of terms in each one of these does not have an effect on the degree that we're looking at. All we're looking at is the highest degree within the entire expression, and that's going to determine what we call it. Now, beyond the fourth degree, which we call quartic, anything after that, we're just going to call the nth degree. So for example, if my highest degree was 5, I'm going to call that the 5th degree. If it's 6, it's the 6th degree. If it's 7, it's the 7th degree. So now we're going to take a look at the examples below, and we're going to decide what the standard form would be, and then also if it would be considered linear, quadratic, cubic, or quartic. Now as we write number 5 in order, we want to make sure that negative 7x to the third is first, followed by negative 3x squared. Then it would be plus 6x, and then plus 2. And because the highest degree in number 5 is 3, that one is going to be considered cubic. For number 6, when I look through all of the different degrees here, the highest degree is going to be 2, so I move the negative 4x squared to the front, followed by 17x, and then plus 12. And this would be considered, because it's a degree of 2, it's going to be considered quadratic. For number 7, the highest degree is 4. So when I write these in order, 11x the fourth goes first, followed by a degree of 3 we don't have. So we move on to degree of 2, which is going to be minus 6x squared, and then followed by the positive 5x minus 8. And because our highest degree was 4 here, this is considered quartic. And then finally for number 8, when I rewrite this, the highest degree here is 1. So it's going to be negative 8x plus 25, and that's going to be considered linear. And there are the answers. Okay, for this next part, we continue talking about some different vocabulary. So again, we've talked about standard form. So if I took this expression right here and I rewrote it in standard form, we know the degree of 4 would come first, followed by the degree of 3, then 2, then 1, our linear term, and then finally the negative 6. Now when we talk about terms, anything that's separated by addition or subtraction is a separate term. So this is going to have 1, 2, 3, 4, 5 terms, and we don't decide that until the example is fully simplified. The degree, we've talked about already, comes from the largest exponent. So in this case, our largest exponent is 4, so our degree is 4. The leading coefficient is the coefficient of the first term once it's in standard form. So I cannot look at the first term here, the coefficient. I have to wait until it's in standard form. So that's the reason that this one is going to have a lead coefficient of 5. Now when we talk about the term, we don't just talk about the number that's in front or the variable with its power. It's the entire term. So the quartic term in this case is going to be 5x to the fourth. Now if you're specifically asked to find the coefficient of the quartic term, then they're only talking about the number that's in front of the variable here. So that would be 5. Then if I ask for the quadratic term, this is going to be 7x the second. That's the degree of 2. And then again, if I ask for the coefficient of that, that's just the number in front. So in that case, it would be 7. Now when we talk about our constant term, that's our term that does not have a variable with it. So if I'm looking through these, the only one that doesn't have the variable with it is the negative 6. And so that becomes our constant term. So we're going to answer some different questions based on this polynomial. Now, before we start answering questions, we should confirm that it is in standard form, and this one is. So in question 9, when they ask which of the following best describes the polynomial between quadratic, quartic, linear, and cubic, we're talking about the degree here. So again, if I look at my highest degree, it's 3, and the term that's going to be associated with that would be cubic. For number 10, what is the lead coefficient of this polynomial? Again, only if it's in standard form can we make this decision, and that's going to be -6 here, because it is the lead of the entire problem. For number 11, what is the cubic term? Now, again, if I'm looking at these different options, the term is going to include the variable with it. Now, cubic is the third degree. So it's this entire part right here, -6x to the third, making that one C. Now we're looking at this example. Again, I'm confirming right away that this is in standard form. And for 12, which of the following is the constant of the polynomial? And again, the constant term is the one that doesn't have a variable with it. And so in this case, that's going to be -7. For 13, how many terms are there in this polynomial? Again, we can judge this because it's in standard form, everything is combined. But we have 1, 2, 3, 4 terms here, so we're going to say B. And then for 14, it says which term has a coefficient of 0 in this polynomial. So that means that the variable would have to have a 0 in front of it, and the 0 in front of the variable is going to make that variable drop out. So as I'm looking through these, the quartic one has a coefficient of 12. The cubic one has a coefficient of 8. I'm missing my quadratic term. So that's the one that if I had to write this in, I would have to write that as 0x squared, and then that's going to make this an answer of C. Now for this example, again, I'm confirming that it's in standard form before I start answering question. The degree comes from the highest exponent, which is going to be 2. For 16, which term has a coefficient of 1? So if I look at first it says cubic. We don't even have a cubic one in this one, so it definitely doesn't have a coefficient of 1. Quadratic, that one has a coefficient of 8. If I look at my linear term, there's no number written in front of it, which means it's got to be a 1. So this is going to be C. And then for 17, what is the sum of the coefficients? My coefficients here are 8, 1, and -5, and sum means to add those. So if I do 8 plus 1 minus 5, I am going to get 4 for that. And right away with 17, we should have realized that it couldn't be B or D because coefficient would not include the variables. Now for number 18, we do want to notice that this says select all that applies, so it could be more than one answer here. Which of the following polynomials below is a cubic polynomial? So since these ones are not necessarily in standard form, I do want to make sure that I'm scanning through and looking for cubic polynomials. Now again, that means that the highest degree needs to be 3. So it's not going to be A, because in A, the highest degree is 4. So this would actually be called quartic. For B, when I'm looking at this one, highest degree is 3, so B is going to work. When I go to C, this one actually happens to be in standard form, so this one has a highest degree of 3, which means it is cubic. And in D, we have a highest degree of 4, so that would be considered quartic, meaning that D would not work. When I move on to number 19, which of the polynomials below has 3 terms? Well, here I do need to do some simplifying, or at least check to see if they need to simplify, if anything can combine. So in this first example, nothing can combine, and I do have 1, 2, 3 terms, so A is going to work. For B, again, I'm going to check to see if anything can combine here. Nothing would combine, and so I have 1, 2, 3, 4 terms here, so it's not going to be B. In C, I'm double checking to see if anything can combine. They can't, and I have 3 terms, so C will work. And then finally for D, again, I'm checking to see if anything combines. They don't, so D is not going to work. For number 20, which of the polynomials below is a 6th degree polynomial? Again, degree means the highest exponent. So in A, that is not going to have a degree of 6. For B, we have a degree of 3, a degree of 6, and a degree of 0. So it is going to have a highest degree of 6, B would be acceptable. And then for C, when I'm looking at these different numbers, the highest degree here is definitely 6. And then finally for D, we don't even have a degree of 6 in this one. In fact, this one, the highest degree is 4, meaning that this one would be considered quartic. So D will not work. So at this point, please make sure that you complete the exit slip that's associated with this lesson, and your homework is in practice set 8.